Hello and welcome. In this video, I'll show you the very basics of antenna design and simulation using Ansys HFSS. HFSS, or High Frequency Structure Simulator, is a widely used 3D electromagnetic simulation tool utilized by both industry professionals and academics worldwide in the design and simulation of various types of antennas. To begin, go ahead and open the Ansys Electronics desktop application. Upon opening the application for the first time, you'll likely see something very similar to this. I'll go ahead and walk through some of the very basic features and aspects of this application before we'll get into the very basics of an HFSS design in Ansys Electronics Desktop. So at the top left, you can see some familiar drop-down menus such as File, Edit, View, Tools, Window, and Help. Under the File menu, you can create new projects, open existing projects, and examples that Ansys provides, and also close and save the project you're currently working on. You'll also be able to, as we'll see in a later video, import and export files and geometries, some of which will be helpful for simulating custom components. Others will be useful for fabricating your antenna. Under the View drop-down menu, you can hide or show different mini windows and tabs, such as the Project Manager, which we can see on the left here is this big empty column with currently just project 1 inserted. If we have multiple open projects, they will all populate here and have their associated hierarchies opened. We can go ahead and, let's say, add the properties window right here, and it'll show up on the bottom left. And if we want to take away that progress tab down below, we can remove it so. To the right of that is this project menu, one of the ways to insert different designs, including an HFSS design, into the project that's currently highlighted in blue here. And at the very far right, we have a help menu, which has documentation about the various features of Ansys Electronics Desktop, including detailed articles on the operation of HFSS. So now that we have our first project, we can open this hierarchy, see that there's nothing inside, except these empty definition folders, and we can go ahead and add an HFSS design. I like to right click on the project so I know which project I'm inserting the design into, hitting insert in this menu, and then insert HFSS design. Now you can see that a few more things have been populated. Under the project, there's a new hierarchy. It's called HFSS Design 1. Let's go ahead and rename that to something more appropriate. First design, for instance. And then we'll see this asterisk. This means to save the project so that you don't lose your work when you quit the program. To the right of that, you'll see that this grouping of different hierarchies and categories has been opened. This will show you different aspects of your 3D model in your HFSS design, and more information will pop up as we add objects. The HFSS hierarchy has a number of features. Just quickly going over some that you'll use to do antenna simulations include the excitations, which will show your input ports to your antenna. The analysis, which is very important, tells the machine how to analyze and simulate your antenna properly. And then this results category right here, which will show you all of the results and reports that you ask HFSS to produce after simulating. So in the center, we can see this viewing screen where there is a coordinate system, a red, green, blue, X, Y, Z vector system. This is where you'll see 3D objects and your model of your antenna once you create it. Currently it is blank, but that is the purpose of this draw ribbon that's been added on the top here. Under the draw ribbon, you'll mainly use the pre-selected commands and sometimes the custom equation-based surfaces and lines to create your custom antenna design. If we want to add an object, we can click on the command and drag our mouse around the window. We'll notice this little black dot follows it. If we click somewhere, let's say I'm drawing a box, I'll start to define the base. I click again, I'll define the height, and then a third click will place the object. So here we can see we've placed just a simple box, and when I click on it, it'll be highlighted in purple. If I click away, we see its color is green. When you hit one of these objects and highlight it, you'll see that under the properties, you can see a variety of features that define how this object looks and acts in HFSS, including its color, transparency, and very important, this model checkbox. When you uncheck this, HFSS will not simulate this object and ignore it altogether, which may be useful for creating visual aids or mathematical references, but not modeled objects. You'll notice that on the left, a new category has been added to this space right here, which is called Model. Under the model, you'll see all the objects, including solids and categories we don't see, like sheets and lines. If we were to add, let's say, a 2D object like this rectangle, by clicking twice, we can see that sheets has been opened up under this model category. Furthermore, if we click on the sheet and click on non-model in the properties, we'll see that underneath that, it is in the non-model category, noting that whether it's in your 3D model or not, it will tell you whether or not this will be simulated when running an analysis of your design. We can close these hierarchies to make things simpler to see as we desire, because they can get quite expansive and complex as the complexity of your design increases. Underneath the solids group, you can see that there's this word vacuum. This indicates the material. Currently, this box is actually made out of vacuum, so it's empty space. But we can change that if desired. The object itself is box 1, which will highlight it if we click on it, and then all the commands associated with it. Currently, we've just created this box, hence the create box command. But if we were to do things like cut it down the middle, add a chamfer to an edge, or maybe cut it a different way, you'll see commands populate underneath this box 1 hierarchy. We can go ahead and do that. For instance, if you hit E on your keyboard for edge, you'll be able to select edges of objects. If you hit F for face, you can select faces. If you hit O, you'll select entire objects. And if you hit V, you'll only select the vertices, so the corners and intersection points. Let's go ahead and hit E, take this edge of the box, and give it a chamfer. So the current settings should be okay. And we can see that this box essentially has been cut in half because its dimensions were quite small relative to the chamfer size. Let's go ahead and change that just a little bit smaller to say 0.1 millimeters and hit apply. So now we can see that an edit has been made to this box, and then a new command has been populated under the box 1 object right here. If you want to ever change the dimensions or values associated with commands, such as the size of the box, you can double click these commands and see the various features. Currently, this box is in the position 0, 0, 0, which essentially means that its origin point, or the bottom corner, is located right at the origin of this global coordinate system that we saw. And then we have its sizes, which are approximately 1 millimeter each in every dimension. And as we saw, the chamfer has 2 dimensions, right and left distance. I set them equal to 0.1 millimeters and was able to create a nice 45-degree cut on our box. If ever your design gets too large or too small and you want to fit it to the screen, you can hit Control D and then also click and drag the mouse wheel and move the mouse around to twist and tilt the design to get a better view of the various aspects of it. You can also go to this coordinate system, spin it around, and turn the wheel here to change the view of your design. Alternatively, you can click on these boxes. Let's hit O for object, highlight the whole thing, and change the transparency to, let's say, something like 50%. That way you can see through it and tell where your other objects are inside of your design. This is quite useful for antenna design, as if you want to see whether or not you've changed the actual size of something behind a wall or inside of a cavity or through a substrate. One very important feature that HFSS allows for is creating relative coordinate systems. These can be added with this relative CS button and allow you to create multiple coordinate systems that are all offset from either the global or each other. This allows you to make really complex designs with relations that are set by variables, such as I want this rectangle to be 1 millimeter above the top of this box, no matter where the box is. This will become useful as you create more complex antenna designs. Let's say we wanted to add a relative coordinate system. By default, HFSS will have this little black dot following your cursor, and you'll see this measure data window pop up, which will show you your distance in the X, Y, and Z direction and the offset that you are going to select were you to press the mouse. But if we want to manually input information, we can hit F4 on the keyboard and we can set the origin of this new coordinate system. Let's say we wanted it 3 millimeters away in every direction from the global. We hit OK, hit Control D. You currently see that our coordinate system is out of the viewing plane, but if we zoom out, we see that it has been added and it is far away from the global coordinate system. And over here in the coordinate systems group, it's been added along underneath it with all of its relative XY, XZ, and YZ planes. So there are many features available in HFSS to create complex 3D designs. I recommend you go through and try most of them, get familiar with how they populate in this model group and hierarchy, and change some things like materials and names, edit commands, and create some relative coordinate systems to get a view of how powerful this 3D object creation toolset is. One last thing I'll go over, which will be useful for creating parameterized designs, are these things called design properties. If you go to the HFSS drop-down menu, go all the way down to design properties right here, we can add essentially variables to your design. Let's click on add. Let's add one called height and make it 1 millimeter. You can just type in the units as such and hit tab and it'll auto-populate the information here. Click OK and we see that the variable height has been added to this properties group. If we hit OK, what we can now do is set the height of this box equal to that variable. If we go to the create box command, which is where it came from, change the Z size to height, this will change the dimension of the box in the Z direction to whatever we commanded, which in this case was 1 millimeter. So you can see it has grown. And when we change the variables back to the design properties window to, let's say, 0.8 millimeter, and hit apply, the box shrinks. And so we can change variables on the fly and the design will auto update. In the future, when you've gotten more comfortable designing 3D objects and have a rough antenna, I'll show you how to set up a very simple simulation and run some analysis on a complete 3D model.